Hi Wildcats. This is an example problem from Unit 1 Focus Question 1. So we will be looking at simple harmonic motion, periodic motion, and period and frequency, which are variables that relate to those two concepts. So problem we have here is you observe a student at a playground swinging on a swing. You time them and find it takes them 1.4 seconds to go from their most forward position to their most backward position. Based on your observations, they want to know the following. Is the student's motion periodic? Is it simple harmonic? They want to know the period and they want to know the frequency. So, step one, always draw a picture when solving word problems like this. So, we'll draw a really bad swing like that. And then, let's see, the student's forwardmost position, we'll say, is here, and then their backmost position is here. And so we time them, and to go from here, their forwardmost position to backmost position, we time them and figure out that this time is equal to 1.4 seconds. So let's start with the first one. Is the student's motion periodic? Well, what is our definition of periodic motion? Periodic motion follows a repeating pattern. So would this student go back and forth, back and forth, back and forth? Yes, absolutely, right? So this is a periodic motion, so that would be yes, it is. Is it simple harmonic? Okay, so that we said is a special type of periodic motion where there is a restoring force that brings the object back towards equilibrium. So first, is there an equilibrium point? And the answer is yes, because if this student just stopped swinging, eventually they would settle out at this equilibrium point, right? They would just stop right there. We know from if you've ever been on a swing, eventually you'll stop and you'll settle right there. So yes, there is an equilibrium point. Is there a restoring force bringing it back? Well, the answer to that is also yes, right? Because what is bringing the student back towards this equilibrium point every time? That is the force of gravity pulling them down. So the force of gravity is the restoring force in this, and there is an equilibrium point, so we can say that is this student's motion simple harmonic? Yes, it is also simple harmonic. Okay, so now they want to know the period of the student's motion. So period is the time it takes to go through one full cycle. So if we don't think about this carefully, we might accidentally put 1.4 seconds. But one full cycle would be, let's say the student's heart's here. In order for them to go through one full cycle, they have to go all the way here and then all the way back, right? That would be one full cycle. Just to the back that's half a cycle. One full cycle is all the way back and all the way forward, assuming we're starting here. Or if we started at the back, it would be all the way forward and all the way back. Doesn't matter. So in reality, the time that they've given us here is really the time equal to half a period. So, because this is the time it takes to go from all the way forward to all the way back. So we need to figure out the full period. We would know that the full period is double 1.4 seconds. So we could just take the period is equal to 1.4 seconds times 2, right? Because this is 1.4 is half a period. So the period is equal to 2.8 seconds. Okay, so 2.8 seconds. Next, they want to know what is the frequency of the motion. So now let's think about what is our equation for frequency. Well, we know that frequency and period are inversely related. So in other words, period is equal to 1 over frequency, or we could rewrite that equation as frequency is equal to the inverse, or reciprocal is 1 over period. Same, right? These mean the same thing. They're just opposite each other. Okay, so if that is the case, then we could just take frequency is 1 over 2.8 seconds, since we just found out period. So 1 divided by 2.8, when you put that in your calculator, I get 0, going to 3 sig figs, 0.357. And now let's look at our unit. Our unit is 1 over seconds, right? I have no unit up top and seconds down below. So 0.357, 1 over seconds. Or, since no one wants to say that, we call that a special unit, and that is called a hertz. So the answer for our frequency of this student on the swing is 0.357 hertz. Okay, so that's kind of an overview of the different things that we would consider as we solve problems related to simple and periodic motion, and hopefully that helps.